Good day everyone. I am Professor Yatnish Kadam from Modern College of Engineering. Today we will be seeing how we can model butterfly valve assembly using Solidworks. So I have with me here Solidworks 2013 version. We will be using Solidworks 2013 to model various components of the butterfly valve assembly. So let's take a look at the drawings. This is the body of the butterfly valve assembly. Next we have the shaft, the retainer, arm, plate, nut and screw. We will be modeling all of these using Solidworks 2013. So let's start with a new file, part file. OK. I'll just dock this command manager. First of all, always check the units. Currently, I will be using MMGS to model this component. Make sure you are using the correct set of units. Now, select to model. Start with this. First of all, let us read this body. Now, I'll make use of top plane to draw the cylindrical parts. Let us dimension them. The outer diameter is 280, the inner diameter is 194. Let us create these projections right now. I am drawing them here. Now I will define this by using constraints. I made them vertical. The distance of the center of this arc is 175. So let us give that. The diameter of this arc, the radius is 50. I will now use circular sketch pattern to pattern the sketch entities. First, by default, the center of the pattern will be the origin, and so I don't need to make any selection here. I will select the entities which I want to pattern. The number of instances I want is 3. Now, if I trim this, the sketch will be fully defined. There are 3 holes which I left out of 47 diameter. We can draw them in the beginning and pattern them also. Using pattern makes us to give less dimensions. Here you can see this thing. It looks like as if this circle is closed, but this is nothing but the leader of the dimension. I exited the sketcher. The height given total is 225. So I will go to extrude. I will give 225. I always like to keep the plane of symmetry in the middle, so I'll make use of mid plane extrusion. So this is the final result, but this is nowhere near to this. So what we will do, the main difference between this component and this part here is the absence of the extruded component here in this zone. So I will make use of revolve cut and remove that. So we can use any plane other than top plane, that is. So I will sketch on the front plane this rectangle. The height of these parts is 32 mm. So since I am removing them, I will keep this distance as 32. I will constrain this, make them horizontal. Next, the rectangle now has to remove material such that it will travel tangential, it will travel normal to the circumference of the circle, not tangential, normal. So that's why this edge should be at a distance of 140 from the center, that is, this edge of the rectangle should be at a distance of 140 from the center. So I will dimension that. And to constrain the sketch, I will just extend this rectangle beyond the boundaries of the feature, and I will give a dimension, a random value 120. Now I will draw a center line to make the axis of the sketch feature, and now I will use revolved cut to finish the job. This is a part of your body. It is still not complete. We have yet to add remaining features, that is this boss and the holes. So for creating this boss, there are multiple approaches, but I will be making use of these basic principal planes to draw them. So here we will be learning about different types of extrude options. So on the front plane, now remember earlier in the starting I had asked you to remember this. I had drawn the sketch like such, while the sketch they had given was like this. This is because I had aligned my sketch in such a way so that I will be able to use the principal planes better, and the orientation of the component will be similar to this when it is finished. Now I will be making use of front plane to sketch a circle. The diameter of this circle is 200. I will constrain that. Next we have to extrude. Now if you observe, the sketch is at the center of the body. If I extrude, the extrusion will start from the center of the body. But is that so? No. Let us take a look at this sketch now. This extrusion is not from the center, but at a distance of 160 mm away from the center. So what I will do, instead of starting extrusion from sketch plane, I will select offset here. The distance of offset is 160. Now coming to the directions, here it will be extruding in the direction which is the opposite of what I want. So I will reverse the direction. I do not know the distance through which it will be extruded. So what I will do is, I will extrude up to surface, and I will select this surface. Make sure the merge result is on. It creates a single body. If I click OK, this is the thing I get. Next, this tail part here, we have to model this also. So how will we do that? Its diameter is 75 and it is at a distance of 325 from this face, that is from this face. So I will sketch on this face right now. Make this normal. I will draw a circle of diameter 75 and I will again go to features, extrude. I want it offset from the sketch plane, offset by a distance of 325, reverse and up to surface. And I have selected this surface. So this is all the additions which we have done. Now let us start removing the material. I will sketch again on this face, this circle of diameter 100. I will have to extrude cut it now. The depth of cut is 25. So I will go to features, extruded cut, blind, depth of cut 25. We have achieved this. Next, again we see that we have one more hole of 556.2. The depth of that hole is 310 from this surface. So let us sketch here. Right click, sketch. (56.2) and 310. Features, extruded cut, blind, depth of cut is 310. Next we have to model these holes. 520.3, 3 places, 15 deep. They are at bolt circle diameter 150 mm. So I will sketch here. I will draw a circle to define the PCD. I will convert it for construction. This is defined. Next, 520.3, they are oriented like this. So I will dimension it. This is defined. I will make use of circular sketch pattern to pattern this circle. The advantage of keeping the plane of symmetry in the center makes it easier to constrain sketches, since by default the center of pattern will always be the origin. It is easier to pattern this hole. Number of entities being 3, equal spacing. Okay. Now we see that though our base instance of the pattern is defined, the pattern itself is pattern components are not defined. Now why is that? Because the center of pattern is still yet undefined. We can see this point which is moving here. So if I constrain it by placing it on the origin, the pattern will be defined. Next, go to features, extruded cut. Depth of cut is 15. So this is the body of the butterfly valve assembly which you have learned to model. I hope you have followed everything. If you have any doubts, you can reach out to me. My contact details are given in the dialog description box. So again, thank you for attending and thank you for viewing this. I am Professor Yatnesh Kadam from PES Modern College of Engineering, Shivaji Nagar, Pune. So good day all.